got the shapes, specific parts of the shapes. Then we'll go into the little surface area formula. Out of the 2 days, this one's usually the more difficult one. The main reason why is because of one specific measurement that we need today that we didn't get. Right?
Oh.
Okay, so pyramid and look, the difference right between pyramid and cone, just like with prism and cylinder, is like the cylinders and cones have circular bases, whereas the pyramids and prisms were polyhedron, right? All made up of polygons. So with pyramids, guys, the one polygon that is like in definition by a polygon is a base. That's the base is in general, with the exception of a section of a triangular pyramid, going to be the one shape that's not a triangle. So the lateral part here today are all going to be triangles, whereas yesterday, like with the prism, right, all the lateral parts were rectangles. So, and again, identifying the base is key for you being able to do the formula. The base is a little bit more obvious on a pyramid than it is with like a prism. Okay, so the base here is going to be the one part that all the triangles are connected to. The triangular prism, if you run into it, it's probably, if it's shown to you, going to be like the tetrahedron was, where it's like 4 equilateral triangles. Probably be a good idea. That's probably the easiest pyramid to draw. Again, for the ones we're dealing with today, guys, we're dealing strictly formula-wise with the right pyramid, okay? And again, right meaning that the height of a pyramid goes from the top of it straight down to the base, okay? The height, if it's directly above it, making a right angle that way, like directly above it, then it's a right pyramid. This one would be an oblique one because it's kind of tilted over to the side. Okay, the height here is not connected right to the middle of the base, so it's oblique. That's the easiest explanation. It's not technical at all. Now, because of this measurement right here, guys, it's kind of hard to see, but a slant height, that is actually the height of the lateral face. Okay, so all your lateral faces are triangles. So the height of this triangle that's on the side is what's called the slant height of the actual pyramid. Okay, so that line, if you can see, it goes down the middle of that triangle. Okay, and for the ones we're doing, it's going to cut it into half on the bottom. Okay, this measurement you need to know in order to do area, because when we do surface area, right, surface area is everything you can touch, so all those triangles are on the outside. To find the area of a triangle, you do 1/2 base times height. So that's the height that you're using in terms of the triangle point. Right? That's why it gets built into the surface area thing here in a second. Okay, so slant height, which, guys, slant height in our formula is going to be like a lowercase cursive L. Okay, so slant height is a key component to our formula. And that, because of this thing right here, this is really the only time people mess up is figuring out that thing. Because you're going to have to be doing like Pythagorean theorem maybe once or twice in order to find it. And also, guys, don't get this measurement right here, all right, mixed up with these two sides. Like these two sides right here are the edges, not the slant height. But a lot of times people are going to use that measurement for this number because it's a slanted side. So they initially think, oh, it's slanted, so it's automatically slanted. Okay? The slant height, like I keep saying, has to be the height of that triangle that makes up the face. Okay, so if you can remember slant height's the height of the triangle, it's probably better than just thinking about it as the slanted part. Right? Otherwise, everything's kind of labeled the same as yesterday. You got bases, you got base edges, you got lateral parts, so on. Lateral still means, guys, when they bring up lateral, it's just not the base. Lateral area would be the area of it minus the base. Okay? Now with cone, okay, cone is a little bit more straightforward, just like with cylinder. Okay, a cone, you don't need to draw. This is the net drawing of it, right? You didn't know the other day, right? I kind of said it once or twice, but net means that if you were to just unfold a three-dimensional shape and make it two-dimensional, that would be the net drawing of it. So the thing on the right, if you want to draw it, that's fine, you don't have to, but at least draw the thing on the left that's the actual cone with the parts labeled. Again, understanding, right, the height, this one, that's from the top straight down to the middle of the base. Okay? That height there that they have labeled, that's height of the cone. All right? Slant height here, which again I said is going to be a lowercase l, okay, put it in the formula, is just the height of this slanted part of the cone, which is easier to identify because I don't have to break it apart as height of the triangle or anything like that. You got a slanted measurement on the cone, it's the slant height. All right? And base is still circle. When we do that, we're still doing circle formulas for the area of the base and the perimeter of the base for the cone. 2 pi r squared for the area of the base, 2 pi r for the perimeter. Okay. So the key things to draw, if you want to label something, at least label yourself as that's the slant height, this side, and the height will be going down. H. Those are like the key parts. And also understanding, like, make sure you have the right angle in there if you're drawing in the height. Okay? Because Pythagorean theorem is going to come up quite a bit today. Okay? Because you're going to be missing probably one of these measurements. Okay? Between slant height, and radius, like for a cone, you'll be missing probably one of those. All right? Some problems will give you everything you need somewhere. Actually, okay, now, just to remind you. Okay, can I go past this? Okay, just to remind you, I'm going to keep bringing this up. All right, just kind of remember, this was up here yesterday, right? Surface area. In general, like the most basic idea of surface area is if you're holding that shape in your hand, everything that you can touch is counted as surface area. Now, I'm going to keep bringing that up because that last day where we're actually doing the composite shapes, like a few of the shapes put together, this comes into play really big. Okay? This is like a huge idea that day. All right? Usually stacking things isn't a big deal, but hollowing them out is. No matter what you do to a shape, if you add shapes together, it's always going to increase the surface. Alright, so just kind of keep that in mind. Even with the problems today, like there's always going to be formulas for this stuff today. There's nothing hollowed out or stacked on. But if you forget the formula, you can always break it up into whatever shapes are involved. Like for the pyramid that was up there, I could have done area of the square on the bottom plus the 4 triangles. And I would get the same answers if I did the formula. Okay? Formula-wise today, for pyramid and cone goes like that. Right?
We did it yesterday.
Alright, so formula-wise, guys, the B and the P part of the formula still means the same thing. The B is still the area of the base, P is still the perimeter of the base. The difference between the stuff yesterday and the stuff today is that slant height portion of it. And the slant height, just remember guys, it's the height of the triangles that make up the lateral faces, right? Lateral faces of a pyramid or triangles, that L, that's just the height of those pyramids, or height of those triangles. Okay, so yesterday we were dealing with, the formula yesterday, right, was 2B plus pH. That was for the prisms and cylinders. The H that was involved there, height, is pretty obvious because it had to be the distance between the bases. Here, it's going to require a little bit more work because most of the time, guys, it's slant height. If it's not given to you, you will have to do Pythagorean theorem to find it. Okay, because slant height makes a right angle. The height of it makes a right angle. There's going to be right angles everywhere, so there's going to be triangles you have to draw out to create these right triangles so that you can find whatever's missing. Okay? If you want to, right, you know, again, just if you look in the book, they're going to have a separate formula for a cone, even though it's the exact same thing that's up there. But remember, in the book, for like cones and cylinders, they go ahead and plug in the formulas. Like for a cone, the area of the base is a circle, so it's pi r squared. All right, perimeter is circumference, so it's 2 pi r. So their formula is going to say pi r squared plus pi r L. But it's the exact same thing that's up there. I don't point out both because I don't want you to feel like you have to memorize more formulas than necessary. Okay? All right, so we'll do a couple of each. Probably some that involves Pythagorean theorem stuff, so all right, so I need people that calculate that. Okay, go past this. Okay, so this is the first one. Right. Just checking to be a right angle there.
Wait, are you asking the surface area or the lateral?
Yeah, we're going to do surface area. Again, guys, if you don't want to draw these, I'm pretty sure I took all these from the workbook. You just go to page, I don't know what page it is. It's section 11. I'm fairly certain I took all of them from the workbook. So you don't have to draw them out. You can draw them out if you want. All right, so
Page 291.
291. Okay. All right, so for this one, we'll do find the surface area. Yeah. All right, so I'll go through, like I said, slow. This one should be easy though because they give you the slant height. That right there is the slant height, and I know it's the slant height because it is the height of that triangle right there. Okay? Again, don't get that number mixed up with that part. All right, so for this, formula is that. The base, guys, for this to work out is going to be a square. That's 6. All right, so area of the base is 6. Perimeter is 24, right? Each side 6 is 4, and slant height was 10. This one is a fairly straightforward problem. Everything's given. You said what, 215? Ah, there you go. Well, look at it.
You have to do that way, or can you just like do it and I'll have an add the
You can, it would have been the base, still would have been 36. And each triangle is 30, 32 to 90. It doesn't matter. you can sit in. Okay, that's an easy one. All right, so this is the next one we'll do. Okay, hoping it's on the same page. All right, so with this one, like I was saying, just so you can have it written out too, like I finally have it written out. Slant height's not given to you. This 10, where it's pointing, is going straight up from top down to the middle. So that's the height, not the slant height. All right. The slant height, if I drew it in there, would be that side right there. Okay. So what I'm actually going to be doing in terms of the whole Pythagorean theorem, because the base is still a square, so that's not an issue, is going to be working within that right triangle right there. Okay? So if I redrew that right triangle, I've got that as 2.5, right? Because this comes from the middle out. All right, so center of that polygon out. Squares are easy to deal with in this matter because I can just cut that number in half. If it was like a different base, if it was like a hexagon or something, then it'd be a little different, a little bit more involved. Okay? That's my height. That's this side. And the slant height in this case is my longest side. Okay? So when I set this up, you just got to make sure that you understand where the parts are. Because if you put 10 as the longest side, it's going to screw it up. If you didn't realize this was the c squared part, again, that's going to change your answer. Okay? So this is the only time you're actually going to have to do a good bit of work for these. And really the only mess up isn't the fact that they go, like you should have an idea and kind of remember as you go through these that the slant height's not there, you're going to do Pythagorean theorem. It's just making sure you put them on the right spots at the right time. All right, so what is what's 10 squared from 2.5? That's holding for 10, 20. Okay. Any square root of that, 10.3, right?
Yeah.
All right, so solving that out, you'll get that. Okay, and then it's just like it was for the last problem. All right, you just go in there, the area of the base, plus 1/2 PL. Area of base is 25, right? The two sides of 5, 5 times 5 is 25. Perimeter is 20. The slant height is what you just found. So that should be 128, right? Half of 20 is 10, and then 1 is 10 with 3 is 103. It should be that. Okay. All right. Just kind of like I say, keep in mind, slant height's not given. If the slant height's given, it should be pretty easy. Okay. As long as, just like yesterday, as long as you're remembering all of the correct area formulas for those bases. If it's not a square, right? If it's a triangle, you remember triangle formulas. The hexagon formula, so on. But if the slant height's not given, just kind of remember, your Pythagorean theorem to find it. Okay? We do one with the cone. Okay, now with the cones, guys, for most of their problems, they're not going to give you the slant height. Like, because cones are very straightforward because it's the base doesn't change, it's a circle. So base formulas and perimeter formulas don't change. So the only way you can actually do any little bit of work for these, like in addition to just plugging them into the formula, is by finding the slant height. Right? So with these right here, which one do you want to do, left or right?
9.
Right?
Yes.
Right? Okay, 9. 9 was first one. 9, 9. All right, so we're doing this one. All right, so again, guys, at the 16, right, they're pointing from the top straight down to the middle, so that's the height of it. Okay? Not the slant height. All right, so again, I'm missing the slant height, I gotta do Pythagorean theorem. It's just like the last one. If you have the height in the basically the half of the base part down there, that's always going to be your hypotenuse. So setting this up, same way. 12 squared equals squared. Solve that out, what do you get? 20. Is that right? No. Yeah. Yeah. All right, now guys, like I said, it's still the same formula for the cones, but your base here, remember, is always pi r squared, and the perimeter is still always 2 pi r, just like yesterday. So again, if you look in the book, they're going to have those plugged in if you look up this formula. Okay? So the area of the base is pi r squared, so pi, 12 squared, so 144 pi. Again, we're going to leave these in terms of pi. So 1/2 the perimeter. So the perimeter is 2 pi r, 24 pi. Um, 144 pi and change. 1/2 times 24 times 20, 240, correct? That's 20, 10, 10 times 24, 240. So my surface area here is going to be 144 pi, 45. Which if I add those up, they give you how many?
Oh, you keep it in form.